All right, so the way that 5 is set up, if you look at the table that's given to you, up top here it says corn and bran. So the way that this is given, that means that the corn muffins are what? Like what goes at the top of our table? The X and the Y. So kind of just a reminder, like that's our X, that's our Y. They use the word max instead of total, but it means the same thing. So a baking tray of corn muffins takes 4 cups of milk and 3 cups of wheat. A tray of bran muffins takes 2 cups of milk and 3 cups of wheat. A baker has 16 cups of milk and 15 cups of wheat. He makes $3 per tray of corn muffins and $2 per tray of bran muffins. How many trays of each type of muffin should the baker make to maximize his profit? So it's set up for us. So the top are the variables, and then along the side are just all the descriptors. So if you have the table set up, it's just plugging in numbers. How much profit does he make from corn muffins? How much profit does he make from bran muffins? How much total profit does he make? That's what we want to find out. That's our goal. His goal is to make the most amount of money. How much milk do the corn muffins take? How much milk do the bran muffins take? How much total milk does he have? How much wheat do the corn muffins take? How much wheat do the bran? Total? I personally think it's nice to write the objective function first because that's the only thing that's not an inequality. So the objective function is the goal. So as a baker, he wants to make money. So which of these lines would be our objective function? The profit. I probably didn't stress this enough yesterday, but all of these numbers that are in the X column, they get an X after them. All of the numbers in this column get a Y. Anything in this last column, it doesn't have a variable, so does it have a variable after it? No. So the objective function will be 3x plus 2y. And if you want, you can cross off that line. It's done, because you'll only use each row once. The other ones are inequalities. So the next one will be, what will the milk equation look like? Yeah, so less than or equal to, because if he has 16 cups of milk in front of him, can he use more than 16 or less than 16?
Less.
Less than. For the wheat one, 3x plus 3y, and then same idea, can he use more than 15 cups or less than 15 cups? Less than. And then there's two kind of gimme ones that we don't need to worry about much. We're not going to have any negative numbers here because we're talking about making muffins. So we have to graph them. So in order to graph this first line, we don't want to get y by itself. Instead, we want to use the intercepts. So we make a little table, and what numbers do we plug in?
Should be for the corn.
For which one?
For the corn. Or the brand.
Right.
Is it right?
Yeah, it's
So
right.
corn muffin takes 4
Yeah,
cups
go
of
back and
milk,
read it.
3 cups of wheat.
Corn
Corn
is
is,
my profits on the top. I'm stupid.
no, you're not stupid. Not even close. So 0 is going on the diagonal. When you plug a 0 in, what's going to happen to that term? It goes to 0. So if you plug in a 0, it goes away. So if you know that 2y is 16, how do you get y by itself? Divide by 2, that's your 8. So that's how you figure out the matching. So now, the second time, where does the 0 go in? On the y. So anything times 0 is going to go away. 4. The second line, when you plug a 0 in for x, what do you get out for y? 5. Because 15 divided by 3 is 5. When you plug a 0 in for y, what does x equal? 5. So looking at this, the biggest number is 8. Is this graph spaced appropriately for us? Yes. 0, 8, 4, 0. Make sure you grab a straight edge and connect them on through. So you use the table with the 2 zeros in it to find the intercept so you know where they cross at. And then you have to plug in zeros again to figure out the shading. We need to know if this line is shaded above or below. So if we plug a 0 in, is 4 times 0 plus 2 times 0, that's all going to be 0. Is 0 less than 16?
Yes.
Yes, so we'll shade towards it. For the second line, 0, 5, 5, 0. When you plug 0, 0 into that one, is 0 plus 0 less than 15? Yes. So the answer is where these two shapes overlap at. So where do these guys overlap at? Well, like what portion of the graph? Bottom left corner. That region shows us all the different ways he can make the corn and bran muffins, but if he wants to maximize his profits, where would maximums or minimums occur at? Corners. So that one's really easy, 0, 0. Where's that one at? 0, 5. This middle guy's at 3, 2. And then lastly, 4, 0. So that's where they could be at. What do we plug into to see which one is actually the maximum? The objective, your profit equation. Use a calculator. Remember, it's just 3 times that in parentheses plus 2 times the y. Zero, zero. Obviously, how much money does he make? 0. If he only makes 5 of the bran muffins, how much money will he make? If he makes 3 of the corn, 2 of the bran. And then what if he just makes 4 of the corn? 12. So with his restrictions of how much milk and wheat he has, what is the most amount of money he can make? $13. So make sure you explain your answer. Like the maximum profit is $13 by baking 3 trays of corn and 2 of the bran. On the test, I've given you like a sentence to fill in the blanks to remind you like you need to write it as a sentence. So just make sure like each of these numbers mean something. Explain what they are for the problem. So linear programming. It's really just a fancy way to write a whole bunch of equations. If you look at the new white packet, this one is what it'll look like on the test. Nothing is given to you. You just have a graph, and then you got to go. The first problem in the white packet is about making bread. The second problem is about making lotion. The third problem is about doctor visits. Would you guys like to do 1, 2, or 3?
Go
3?
Yeah, 3.
3? Okay, we can do 3.
Always the last one. Maybe one time you read your last.
Okay, so which one's hardest? I mean, they're all pretty similar, but I would say like 1 and 2 are very similar to what the one we just did because it's like baking something or making something, which is the same as baking something. This one has like one thing that's a little different. So if you're looking for something that's different, so 3 is okay? Okay. All right, a doctor allots 15 minutes for routine office visits and 45 minutes for full physicals. The doctor cannot do more than 10 physicals per day. The doctor has 9 available hours for appointments each day. Each routine visit costs $60 and a full physical is $100. How many routine office visits and full physicals should he do or should the doctor do to maximize their income? What is the maximum income? I'm just moving this all down. Okay, so step 1, whenever you have to do the linear programming, just automatically make this table. if you want to write total, max, whatever, doesn't matter. And then you got to figure out the variables. So go to the very end, and we're being asked a question to figure out what? Go back one sentence. How many of each type of visit she should do. So whatever question you're being asked at the end, your variables have to answer them. So in this case, what will our X stand for? Routine visits, and then Y will be the physicals. So just go to the question, whatever question you're being asked, like how many of each type, those are your two variables. And then you can go in, and all of the numbers are going to have descriptors with them, and that's what goes along the side. So what are some of the descriptors we're given?
The minutes.
Yeah. So the time, how long things take. So how much time does a routine visit take? How much time does a physical take? How much time does she have to do this all? 9 hours. Okay, so we have minutes, hours. Do you think that's going to be okay? No. So you have to decide. Do you want to change them all to minutes or all to hours?
Minutes.
I would do minutes in this case just because the 15 and the 45 will both be fraction or decimal, and usually it feels a little bit safer to not have that in there. So you get the same answer if you don't, but I'm just going to do minutes. So 15 minutes, 45 minutes total. How many minutes does she have?
500.
540. So just make sure you multiply that 9 by 60. What else do we know?
How much money?
Yeah. How much money is a routine? How much money is a physical? How much total money? Star. That's our goal. She wants to see how much money she can make in a day. And then this is where this one's a little bit unique. What's the only other number we're given? That 10. Okay, so is it 10 physical, 10 routine, or 10 total?
10 physical.
If you reread it, it says you can't do more than 10 physicals per day. So that 10 physicals has to go right here. So she can't do more than 10 physicals a day. Can she do less than 10 physicals a day?
Yeah.
Can she do exactly 10 physicals a day?
Yeah.
So Y has to be less than or equal to 10. So that's where this one kind of gets weird because she has like a rule she has to follow, a restriction, where it's not 10 total, it's just of this type, she can only do 10 of them in a day. Anything else we need to put in this table? No. So step 1, objective function, which is going to be her profit comes from
60.
that line's done. The other equation we have will be the 15x, 45y, and then 540. So if she's going to work that many, can she work more than 540 or less than 540? Less than or equal to, because if she has her work day, she's going to schedule it to fit within her work day. And then even though this is kind of weird to write in your table, like didn't we already write our other equation right there? So that one is done. And then just like all the other ones, can she really give negative like exams? No. Once we have that, which equation is going to cause us the most issues, if any? The big one. So figure out this guy first. So figure out where that is going to change by. Because here we have to do all of our labeling and all of our counting ourselves, so we need to figure out what it is. So if you plug a 0 in for x, cover that up. 540 divided by 45, what do we get?
12.
And now plug the 0 in for y. 540 divided by 15 is 36. And then obviously that one's up at 10. So if you go down here to your graph, do we have enough space to count by 1? No. So if we have to get up to 36, what should we count by? We can count by 2. So remember, you can just label 2, 2. You don't need to label every line. Just label that you're counting by 2s. And then just make sure you put a little label of like, these are my routine. These are the physicals. And then we're just gonna plot those 2 points.
It's all at the end.
Like you have one more and then the end. Grab your ruler. When you do the shading, so you plug a 0, 0 in for both of them. Is 0 plus 0 less than 540? Yeah, so will we shade above or below our line? Below. So there's our first line. Our second line is Y and then a 10. So if it's just Y and 10, what kind of line is that? Horizontal. And then it's a more equal to. And if you want the Y's less than 10, will that one be shaded above or below? Below again. So where do these guys overlap? That bottom left corner. So that region is all the different types of appointments she could schedule, but she wants to schedule so she gets the most amount of money. Where is the maximum going to occur at? One of the corners. So it is the corners of the shaded region, not the corners of your lines. So just make sure it's just whatever is touching your shaded region. So our points are 0, 0. Straight up is 0, 10. What's this upper right one? 6, 10. And then way out here at the end, 36, 0. And then to figure out which one is the maximum, where do you plug them into? Yeah, the objective function. So 0, 0 is obviously 0. What about 0, 10? $1,000. What about 6, 10? $1,360. And then 36, 0 would be $2,160. 36 times 60. So that means, what is the most amount of money she can make for a day? 2,160. And in order to do that, she should schedule
36 routine.
Yep, only 36 routine visits. So just make sure you describe your answer in the end. The rest of the time is yours to work. You guys have until noon in here. So the linear programming, that leaves you 2. If I'm being honest, if you haven't done yesterday's yet, I would work on the ones in this packet just because that, like, the full setup of tomorrow, and then, or for Friday, and then tomorrow's just a work day. You have the 3 parts of the review, so you got all you need.
So tomorrow's just work day on these.
Yep, and then what's in classroom.
Is this class full period?
No, it's been down.
5th hour's full.
So what time is class?
We just label it all. So like whenever I write physical and routine, like that's just saying that. The constraints or the inequalities, you just write and then you go. So like someone else made this and they don't use a table to organize stuff. The vertices are just the corners or constraints or the inequalities. So you have all the parts.
Oh.
And in reality, like I don't care where you take this stuff.
Should we go in?
I do.
Yeah,